For every action, there is an equal and opposite reaction. This was fundamentally Isaac Newton's third law of physics. This law had brought humanity to greater heights. Literally. Rocketry, for example, uses Isaac Newton's third law to propel rockets into outer space, bringing payloads such as satellites, rovers, and on a few instances, humans, to distant, far-away worlds. For example, because of the Titan 3E rocket, Voyager 1 was able to give us a better means of understanding of our outer solar system. In this video, I will demonstrate with a balloon, string, and tape how a rocket uses Newton's third law to propel itself into outer space. So come on, let's proceed. You can see here how I set up my experiment. I tied a string on one end of my room, the balcony window, to a pull-up bar at my door. The string was also placed through a plastic straw. This plastic straw will act as a track for our DIY balloon rocket. Air blown by my lungs will act as the balloon's propulsion force. The more the air, the further the balloon will go. I attached the balloon to the plastic straw using tape. Now, we stand by for launch. Okay, that balloon went really fast. Let's see that in slow motion. What you just saw was Isaac Newton's third law in action. But first, let us recap what the third law really means. By definition, it means that in nature, for every force, there is an equal and opposite reaction. In other words, if object A exerts a force on object B, then object B will exert an equal and opposite force on object A. But what does that really mean? Let's look back at the video. As you can see, the balloon propels itself forward by pushing air backwards to make the balloon move forward. Aha, you see? Opposite directions, just as Newton's third law states. I'd like to take this opportunity to compare the balloon to a real rocket, such as the infamous Saturn V seen here on the 16th of July 1969. Just as air propelled the balloon, Newton's third law allowed the kerosene fuel to produce a strong force downwards, lifting Apollo 11 upwards into low Earth orbit and ultimately to a faraway celestial body known to us as the Moon.
Plus 30 seconds.